Hi, first of all, very nice to be here. Thanks for the invitation. And I will start with apologizing you because I'll probably have not enough time to cover this topic. It's very broad. And I have to confess that I decided to talk about things that I find interesting, and maybe you'll find something interesting in that as well. So first I will introduce myself. I'm by profession a physicist. I did my PhD in theoretical physics at University of Warsaw. Then I worked in academia in research in Poland and abroad. And then I moved, as many of my colleagues, to data science. So many physicists work as data scientists. And currently I work in Warsaw at DeepSense AI. But after work, I like to write songs. I'm a songwriter, singer. And I never thought that these two activities of mine will have a common space where I can talk about them together. But actually, artificial intelligence and data science turn out to be a possibility for that. So the topic is very broad. And as we know, tomorrow Gene Kogan will talk about, I think, neural aesthetics. I don't know the details of his talk. But there's a number of art projects or artificial intelligence related projects that are being developed, and you can Google that. I don't want to talk about slide transfer. I'm not going to talk about GANs. I don't have experience in that, and I can recommend you Googling and searching, and we can talk about AI as being a new means of artistic expression. And we can use AI in art education or in education in general. And I think a very good idea would be for artists to talk about artificial intelligence, to communicate to the society about what artificial intelligence can bring. But I'm also interested in more general questions, or slightly different questions about creativity, because I like doing stuff, I like creating stuff. I don't know how about you. But I guess all of you have been involved somehow in creative processes. I don't know if you had a chance to analyze them or how they are being processed. But whenever we are talking about creativity in art and artificial intelligence, I think it's a good idea to define what we understand by that. And I think art is not creativity because, for example, we talk about kids being creative, and that's true. They are very playful. But somehow we do not display their artworks in Tate Modern or Tate Britain. So not every random combination is artistic or is interesting. Art is, I think, more deeper thing. So I would like to touch a little bit about creativity, and I'm interested in how we could perhaps characterize creativity as a computational problem. Okay, so from the perspective of data science and machine learning. But I'm going to talk about two things today. So first thing, which was a motivation to come here, to PyData, is a result of a HackArt hackathon organized this year by National Museum in Warsaw. And of course, I forgot to mention that on a daily basis, as a data scientist, I work in Python, obviously, so that's why I'm PyData. So I'm going to talk about that, and then I'll try to maybe not give you any definite answers, but hopefully give you some interesting open questions about how we can look at the creative processes. Okay, so HackArt, maybe some of you heard about it, maybe some of you have been there. It was a hackathon organized by two ladies, Ewa Drgalska and Sylwia Żukiewska, at National Museum in Warsaw, and the idea was very cool. It was to bring two very distant concepts, so concept of machine learning and artificial intelligence, new technologies, and art history, and put them together and work one for the other. And they presented us with a number of challenges, and they gave us a data set of 200 images of paintings and sculptures. And there were 40 participants. It was in the end of May in Warsaw. And my team, we called ourselves Team DS, DS from Data Science. That was a temporary name, but it remained. And we were Ola Rutkowska, Karol Majek, Paweł Zięcina, Piotr Migdał, and me. And some of us work or collaborate with DeepSense AI. So we went there to the hackathon with completely different idea. It was about recognizing doppelgangers on images, but it turned out that Google did something already like that, so we had to find for a different idea. And what we did was to target a specific group, target group for museum, kids and families. And we created a game in the form of a web app. We call it Museum Treasures. And when working on it and defining this game, we focus on 3 specific questions. So how to encourage families to come with kids to the museum, how to make the visit in the museum fun. And I want to stress that because in this approach, artificial intelligence was a tool. It was not a central actor. It was not, the aim was not to show off the possibilities of AI. The aim was to solve the problem to attract kids and families to the museum. Okay, and we had just 2 days for that. So the game Museum Treasures is based on the observation that kids like to find things. They like to search things, for hidden treasures. So we based on that our solution, and the idea is that the game shows you a number of categories from which you can choose. You choose the category and you search for objects of that category in the museum. What are these objects? So we show you fragments of paintings, and your task is to find paintings from which those fragments were taken. So imagine you're a kid, you are given a category, you choose a category animal, and you have, 10 fragments showing you dogs, horses, cats, and we give you all the information about in which room the painting is located. The rooms are big, so there are many paintings in one room. So you really have to go there, you have to look at the paintings, you have to find the fragment. And the simplest version of the game is without verification. The more advanced would be with verification. How does it work? So basically you have a set of you need a set of fragments, so you need to sample from some dictionary of fragments. And we were given a data set of images, so that's your starting point. Then you have to convert it into a dictionary of fragments of given category of meta category, and then perhaps apply some automated or supervised filtering methods. And then at the end, this is sent to the application, and the user sees the set of categories, chooses one category, and see the sampled specific number of fragments. So the AI part comes here in helping us translating the set of images into the dictionary of fragments. And how we do that? We do that with object detection. So that's one of the deep learning models that, given the image, it will recognize specific categories on an image and draw bounding boxes on the image, giving also the probability, so the accuracy telling you whether it's sure or not sure that this is the case. Okay, so this is a schematic way of how object detection works. What were the issues? The issue here was that our data set was very small, only 200 images. But more importantly, we didn't have any labels for the data set, so we didn't have any ground truth bounding boxes. And moreover, I mean, the data set was small, and we were not sure whether we would have enough elements of each category that we would like to have. And of course, wrong predictions, what to do with them. Okay, given the model, I mean, it will not be 100% performing. So our approach was at that point during the hackathon to use already trained model from a Google Vision API. And the model was faster RCNN type. It had more than 500 categories. And we passed the entire data set through the model. Of course, you may ask, do we want to do that online or offline? And in this scenario, it is enough to do this offline. So you take entire data set, you send it to the model, and you prepare the predictions offline. Of course, it can be done online. You can build an app which will make predictions online, but that was not necessary here. And what was necessary to make sure that the predictions are good quality, because we are working with kids, and if you present, and if you make mistake, and you tell the kids that it has to look for a cat, and you show it him or her, I don't know, a car, I mean, the kid might be disappointed, and we don't want that. So really, quality is important. So for the demonstration during the hackathon, we had to ourselves go through the predictions and see how the model worked. Okay, and I'm not going to show you the demo, but you can go to one of the blog posts, either at DeepSense AI blog or at Medium. Eva Drgalska from the museum, she created a nice blog about new technologies and museums. So the description of this idea and the project is there with the links to the GitHub. and the demo. But I wanted to tell you what happened next. So we won the first place in the hackathon, and then we agreed to do a pilotage. And for the pilotage, so we really wanted to have kids coming to the museum and checking out this idea. And for the pilotage, we were given a new set of images from the galleries of 19th century. These were like 260 images. And it again turned out that, of course, the model detects many categories there, but sometimes you have like a category of, I don't know, a fish, and there are only 3 fishes, so you cannot use this category to sample from it in the app. And that's why we created meta-categories, and for example, body parts is a collection of more specific categories. Animals is also another meta-category. So it was not done automatically. But what we wanted to do was to also introduce filtering, and this is what we are working on now. So filtering the images with high probability bounding boxes, filtering the fragments that are big enough, and so on. So there is a set of ideas that for these filters. Next thing is the verification. I told you that the basic idea of the game was assuming that we don't have a verification method, automatic verification, but we can use that, we can do that with introducing metadata of the painting. For example, ask the kid to introduce the year of the painting. And another idea here is also to perhaps introduce hints. So we may use AI model that generates descriptions for images and try to do that with our images of paintings. However, the most important part are the predictions, and so we took the new data set, we passed it through the model, and you can see that sometimes it works nicely, sometimes not. So the upper row shows you the images with some specific categories identified there, and you can see the first left is microphone. That raised my suspicion immediately. It's not a microphone. Now, interesting examples with sculpture, because sculpture sometimes works nicely, like on the second left image, but the third one is not. And I think it's an interesting observation that the model really has to do a very difficult task here, because imagine that a painting is already a representation of reality. And then within a painting, you have another representation of reality, a sculpture. So how the model can distinguish between a person in a painting or sculpture in the painting. So that might be very difficult. Tableware, it's fine. Furniture, yes. The lower row represents already the fragments for some meta categories. So animal, like a nice dog. Now the second one, animal, it's a bit strange. Well, it's a human. The third one is plant, so probably it's a flower. The fourth one is interesting because the style of the painting is very strong here. It's very different from the image. However, still the model was able to recognize a person there. Now, architecture and food is also very interesting, like especially food. I think that might have been a hen or a chicken, I don't know. But this is, well, not. So how to improve that? Of course, you can look for a better model, or you can really train your own model to have more control. And one of our ideas here that is not yet done, but it's an idea for experiment, is to really use style transfer as a method for data augmentation. Because I had this idea before when working on one of this year's data science bowl problem with detecting nuclei. It didn't work, it didn't help. But here, data augmentation with style transfer actually might be working, because what we can do, we can choose some object detection model, download weights, download the data set, perhaps choose a subset with specific categories there, and pass it through style transfer offline with a style from, for example, the 19th century paintings. And then continue training on that subset to see if it helps with very difficult objects. So that's our idea, and that's what's happening now in terms that we are preparing the code. We are working on some filtering methods. We are verifying the predictions. We need to have some improvement in the front end, but we are planning to really have a test in museum. So I hope in the near future I will be able to invite you all to the museum to test the game. And if you'd like to read more, please go to the blog post. So that's the first part of the intersection of art and AI. Now the second part is more, I think, higher level. And as I told you before, I'm not going to give you like definite answers, but I would like to show you some observations. So probably all of you have been involved in some creative processes, but maybe not analyzed creativity as a process itself. But what we know is that creativity involves exploration, randomness, playfulness, and there is no stress. Well, there is no space for stress, so there should be a space for free exploration without judgments. So it's a space where we can make mistakes and nobody is judging us. Contrary to the phase of execution, when once we have an idea and we need to execute it and we need to develop it, then we really need discipline. There was a nice talk about creativity by John Cleese on YouTube. I don't know if it's still there, but if there is and you are interested, I can recommend it. Now, people thought about creative process like a long time before, and this representation was done by Hermann von Helmholtz and Henry Poincaré. So in creative process, I mean, you can actually identify very universal stages, and this comes from people who are working in arts, science, it doesn't matter, okay? You have a stage of saturation, you have a stage of incubation and illumination. Sometimes we add to this a verification. Now, saturation is when you define a problem, you gather information, everything you can about the problem, you dig into the problem, okay? You can compare it to the creation of some kind of data set of experiences related to the task. Now, later, you have a stage of incubation, which is subconscious, and it's unpredictable in terms of time. It's not guaranteed that you're going to find a solution of a problem, that you're going to find a brilliant idea, but when you find it, it usually comes as an aha moment, a moment of illumination, and that's a signal from subconscious to conscious. Okay, so it may find you when you are walking home from grocery store and finally, I found the idea. Later on, you may verify it at home. This happens, for example, in scientific discovery when you have an idea and you need to check some additional calculations and so on. But this is a very general stage. Now, example from songwriting. Maybe songwriting is not the easiest way of talking about creativity because it's quite a complex process, but I like writing songs, so I'll give you a simple example. Now, imagine that you have to write a song about urban story, related to some building and a story from a city. It's actually from my hometown. So I was working on that. I had a nice idea for the chorus, and I was digging into reading stories related to that building, to that particular history. And then I left it aside because I didn't have an idea for the first verse. So I left it aside, and in the meantime, in my workplace actually, I put on a display one of the images related to the story, and it was there for weeks. And at some point, I came with the idea of first verse, which actually, if you can read it, is about bright light. So actually it resembles the image that I was using to enhance it in the meantime. Now, of course, it's a tiny example. It doesn't mean much. You can look at the process of songwriting, creating lyrics from AI perspective, and there are many projects that do that. Quick Google search shows you this project. And what they did, they used LSTMs for generating lyrics. And they say that what you need in the model is a seed word or a phrase, and the model will generate a lyrics in a style of a specific artist. So, yeah, that's not something maybe unexpected. But if you ask songwriters how they do work on songs and creation of lyrics, it's actually a deeper process, because it's not on the layer of lyrics. Well, lyrics is the end product, yes. There is a very good book on writing lyrics, and there is a very good, very popular exercise on creative writing. I can recommend it to you. It's called object writing, and it's a very short exercise that is creative, and the idea is that you take a seed word, You can take it from a dictionary, you can take it from a website, objectwriting.com, run by Pat Pattison, the author of the book. And then what you have to do is to generate a scenario inspired by the word. So I tell you, for example, coffee and things that appear. So you create a stream of consciousness, a stream of associations. But there's a very crucial assumption here that you have to stay sense-bound. So you create you generate a world around that concept, and you stay close to your experiences related to the senses. That's also important from the perspective of the lyrics, because senses and these sensual experiences are something that everyone can relate to. That's why they are very powerful in the lyrics. Now, you do that for 10 minutes only, and this is not more, not less. And the purpose of this exercise is to make it easier to you to dig into and to dive into your imaginations and easily generate the worlds. And I would like to see something like that, some kind of experiment like that in the domain of machine learning. Because the end product is the same as the project from the previous slide. But you can see that the process itself is different. It's image-based or sensual-based. It's the lyrics is the upper layer here. And maybe you heard about this. This is a project that was announced, or the product announced this week, Promethean AI. And it's a product from a game industry, which is a tool for artists that generates templates of world. Of course, it's not as good as humans, but the aim of this is to generate like the template on which you can work. Okay, so in a sense, it's also we see that these things start to happen in the domain of AI. Okay, but coming back to the creative process and trying to understand it, and I would like to dig into it because I would like to understand better human creative process, and I think that machine learning experiments can perhaps help us doing that. So we had saturation, we have incubation and illumination. And what is interesting is the stage going from incubation to illumination. Because if you go from subconscious to conscious, then the signal must be very strong. That's one observation. And as a physicist, when I hear about that, I think maybe there's some resonant effect that promotes, really enhances some specific signal. The other observation is that once you find the one idea, you have this gut feeling that this is the one, and you do not search more. So perhaps from the physical process, you've found some minimum, or you've been rewarded, and also that there is no guarantee that you're going to find the solution. So it's like finding a minimum. Maybe you will not find a minimum. So maybe there's some kind of a multidimensional space, and there is no guarantee that you find a solution. And there are multiple, probably, good solutions. So there is no guarantee that there is just one solution to your task. Okay, so maybe we could think about this also in terms of a game, and in terms of, for example, reinforcement learning, where you have agent playing in the environment, sending actions and receiving rewards. Maybe the brain, or this is a process that somehow is kind of like a game. But if it's like a game, then the question is, what is the environment and what is being rewarded? Okay, so the environment could be, for instance, a space of concepts or our experiences or our memory. But if you have a space, then we would need also concept of the proximity or the measure of the distance. Now, if you treat the memory like a huge database of experiences, then perhaps proximity is related to co-occurrence of various concepts. Okay. Now, the other thing, what is being rewarded? Often we say that creative process or creative ideas are the ones that bring very distant things together. That is something that is unexpected. Okay. But we often see that these ideas, the best ones are the simple ones. Or there's also a concept of familiarity. And I will give you maybe an example in a moment. And what I think is important is that not every random combination of two distant concepts is interesting. So it's not only about exploring the space and putting distant things together. So I'll just give you a tiny example here. So imagine that you have a task of writing a song that is very short and catchy, but the subject is transparency and public information. So this is the real life experience. I did this, so I sometimes support one of the NGOs in Poland, and they work with these topics. So as you can imagine, this is not the most romantic topic for a song. But anyway, we managed. I managed to. There was a songwriting challenge for me, but the solution was that I wrote a short song based on tongue twisters. And now you may ask, what is the relation between tongue twisters? And you may think that these two things are very distant concepts. So how you bring them together and why this is a good solution. And it turns out that there is actually multiple paths how you can connect these two ideas. They are very distant, yes, but you can bring a mutual context for them to interact together. And there's also a sense of familiarity for the tongue twisters because this is something that everyone heard of. Okay, so I think this is my last slide, showing you that from one concept you can go to another one which is very distant in multiple ways. And perhaps this is something that could be one of the things that is being rewarded in such processes, that if you have, you search for randomly for a very distant concept, and then you try to link those concepts. And if you think in terms of machine learning models, imagine you have a model that is object detection and you have thousands of categories. And you can ask, okay, which categories are closer to each other in the space of categories, in the space of representation? And on that, you may search, well, on that basis, you could perhaps design a simple experiment that could mimic these, or that could represent these ideas. Thank you very much.